It's on, yay. I was just waiting for a few minutes till everybody's seated. You could talk amongst yourself. I was just checking if the microphone worked. Well, it works. Does everybody hear me in the back? Hi. Come in. All right. Oh, yeah, I have to start. Okay. Wow, welcome to Cloud Native London, everybody. You made it. You're here. That's great. Obviously, there's been lots of news happening today about event cancellations and all that kind of stuff, but you're here. Everybody's happy. I'm happy. So yeah, let's get a move on.
Also a possible flood by.
So, who is Cloud Native? It's a strong, open, diverse developer community dedicated to the Cloud Native platform and technologies in London. We'll be tweeting tonight at obviously hashtag CloudNativeLon. This is me. For those of you who don't know, my name is Dominique. I actually help Shell and Co out with organizing Cloud Native. I'm not that often on stage, but if she's out, then I'm in. So I am working for Babylon Health as a developer relations and community manager, do some other stuff like Docker London and DevOps Days. Got all social things here if you'd like to follow me or add me on stuff. The agenda for the evening is as follows. First up, we've got Richard from Worldwide Technology, and he'll be speaking about Cloud State of Play. Then we have Pradeep from Cloud Native Technologies, and we've got a short break, and then hopefully my third speaker will arrive, because I don't think he's here yet, but I've been told he's in a meeting, so he'll be making his way, and that's Nadir from VMware. Few shout-outs to the sponsors. Is there anybody from Technovo here? I don't think there are. Technovo is a digital consultancy focused on the cloud-native space and DevOps things, also my former employer. Is there anybody from Contino here? All right, Contino is also a consultancy doing different things. This is, would you like to say something about Pusher? Oh, right, you're not Pusher anymore. Okay, is there anybody? Sorry, this is a long week. Is there anybody else is there anybody who's currently working for Pusher? Did you learn anything? Pusher makes real-time APIs that power communication and collaboration apps all over the world, supported by easy-to-integrate SDKs for web, mobile, as well as the most popular back-end stacks. And then xMatters. Anybody here from xMatters? I'm just going to assume no. I'm just going to read whatever's on my screen. xMatters' digital service availability platform helps you solve technology problems before they become business problems. Sounds quite impressive. Even more thanks. Apparently my slides didn't update, but is there anybody from Humio? Humio is a time series log management solution for unrestricted event analysis, scaling to multi-TB/day, on premises or hosted. Sorry, I'm being silly, but we're very happy that the sponsors are helping us out with the pizzas and everything. I saw somebody from SUSE. No, yes, no. I'm just going to carry on. Cloud Application Platform introduces new capabilities that move businesses forward, enabling IT teams to embrace the need for speed, quotes, and accelerate application delivery. I mean, the marketing team is doing a great job. And then DTIQ, formerly Mesosphere, is the leading provider of enterprise-grade cloud platforms that enable organizations to embrace open source and cloud-native innovations while delivering smarter day 2 operations. Okay, cool. Moving on to the community stuff. We are also a great supporter of Meetup Mates. Is there anybody here from Meetup Mates that had a pre-meet tonight? Yeah. Yay! They're all in the back. For those of you who don't know what Meetup Mates is, it's a community run on Slack for people who are interested in going to meetups together. If you don't have anyone to go with, generally they meet an hour before a meetup happens and then go to meetup together. So you're always with someone. And it's nice. It's a nice group of people, all friendly. If you want to be a part of it, you can go to their website or on Twitter and have a look. In more community news, it's almost September, so I'm assuming this will not affect any of the recent cancellations and postponings. But Kubernetes Days is coming to London, as Cheryl has said the last few weeks. That is going to be the first week of September. I forgot the dates, but I think it's the 8th and the 9th of September. It's going to be at the Emmanuel Centre in Westminster, so that should be good. The CFP should be live. I think the tickets are almost live, so if you want to have a 2 days filled of Kubernetes community learnings, then go to that website and register your interest.
Especially with KubeCon cancelled, this might be the biggest Kubernetes event in Europe of the entire year. Good point.
KubeCon is going to be postponed to July, August, so that will happen before this happens. So, I mean, I'll let that up to the CNCF to inform everybody about, but this should be a good event. More community news. DevOps Days is also doing a CFP at the minute. If you scan this nice QR code, that should work. DevOps Days is coming at you in September 24th, 25th. It's at the QE2 Centre, also in Westminster. It's always a very fun conference. No, it's nice and small. And the tickets are also live, so if you want to propose a talk, or if you want to be a sponsor, you can come to me. Or if you just want to have a ticket or anything like that, one of my favorite conferences in London. If you want to participate or speak at this event, you can go to Cheryl's website. I think the next available slots are in 2021. You can say something, but that's some serious organization. I mean, you know, very good. If you want to be a sponsor, you can, you know, come up and do the little shout out yourself. You can also have a look at Cheryl's website, and everything should be there. There's also a Slack channel, and obviously we're on Twitter. I think that's my slides. All right, Richard, I would like to invite you up on stage. Give a warm round of applause and have fun. Oh, I forgot something. I'm a terrible human. Okay, while you're setting up, it might actually be a good thing. I would like to invite Ilias from Sainsbury's on stage to talk about why we're here.
Hi everyone, I'm Ilias Bertsimas. I'm a cloud engineering lead for commercial at Sainsbury's Tech. Thank you for joining us tonight. And at Sainsbury's Tech, we do a lot of engineering, and we love cloud-native technologies. And that leads us to the obligatory we're hiring. So if you're interested, take a look at Sainsbury's jobs, or come to talk to me afterwards, and chat me up about anything around cloud-native technologies, Kubernetes, anything you want. Thank you. Enjoy the talks.
Thank you, thank you. So I think before you can just take it off and put it on the thing. Before I forget, just make a selfie for Cheryl, because she always does that, and I generally forget. So can we just like move in and all say hey? Hey! Thank you.
Can we get a copy?
It will be on my Twitter in approximately 5 minutes. Yeah, if you want. You can also use that one if you wish.
Can you use this one? Can you hear me? Okay, excellent. Oh, sorry. Yeah, there we go. Right. I'm glad that actually people managed to turn up tonight. For a minute there, I thought it was going to be all cancelled and nobody was going to turn up. So, great to see you. Great to see you. Okay. Right, so good evening. My name is Richard Simon. I work for a company called Worldwide Technology. You probably never heard of us. We're actually probably the IT industry's best kept secret. More about that a little bit later on. Just an intro for me. See some of the prestigious companies I've worked for in the past. Now, I've actually got a nice sort of special thing that I'm going to announce with you tonight. I'm actually celebrating 30 years in the IT industry, so I've put a question mark on that. I've put a question mark on that, and you'll see why in a minute. That's what I looked like back in around 1994. So if you've worked in the IT industry for as long as I have, this is what happens to you. Okay. So, yeah, I'm just really, I'm not really a sort of a huge techie, so my focus is really kind of working with our customers to make sure that they have a good strategy in terms of how they're really migrating to the cloud. If they're already in the cloud, how we can help them sort of optimize that, and also to make sure that organizations have the right sort of strategy when it comes to cloud. That's kind of really one of my main sort of roles. So I'll be kind of just talking very quickly about a few areas, just kind of pointing out a few items to you around things like journey to the cloud, so how people have actually sort of migrated over the last few years, looking at things like the sort of migration strategies, some of the things that have actually worked in how sort of organizations have migrated to the cloud, and then kind of how, you know, why is it so important to actually have a good architecture when you actually come to migrating to the cloud. And we'll kind of just drop some conclusions towards the end. I will try and give you some time for Q&A, so I promise to do that, so at least 5 minutes, if not more, and we'll see how we get on. Okay, so journey to the cloud. I guess that's probably one of the best ways to describe what a cloud is. Okay, so I think digital disruption is probably one of the main things that is affecting the way organizations are actually looking at IT and how they really move forward with their infrastructure, how they move with their designs, how they move with their architecture going forward. So we've seen the rise, obviously, of things like public cloud, and we've kind of seen the reduction in on-premises technology as well, and all of that's kind of converging, off-premise as well, being kind of part of that. But kind of that's all sort of converging around this area where really organizations are moving to a cloud architecture, if not a multi-cloud architecture. Actually, I do have a few customers that are doing multi-cloud, which is great. So, you shouldn't really just move to the cloud or use cloud technology just for the sake of it. Okay, that's really important. The idea is that you actually try and take advantage of the cloud technology properly, versus actually having just say, well, we'll just use container, just put it into a container, or throw it into Kubernetes or something. That's really important. Okay, so I put this chart together. I've been kind of developing this for a number of years now, and the idea really is just to, for my customers, really, I normally tend to sort of whiteboard this with them, but what I'm trying to really just kind of show customers the journey to the cloud and how, you know, they themselves or other organizations have sort of moved across sort of from left to right. So on the sort of the left-hand side, we have things like the traditional IT technology, the heritage data center, and all of the sort of technologies and solutions that are in that space. So you can't call it legacy, by the way. Not allowed to say that. It has to be heritage. So traditional IT, we've had sort of, compute, storage, networking, etc., all sort of happening in that space, and that's been kind of developing over the last few years. So that's really where things like monolithic applications really sort of run at the moment. And you may be surprised to hear, but around 80% of applications are still in the data center. So despite all of this sort of movements into cloud. One of the sort of technologies or areas of technology that kind of developed over the last years is what I call sort of transitional IT. And this was kind of a knee-jerk reaction to the traditional data center technologies, and where customers really wanted to, or organizations wanted to, really get out of some of the licensing, crippling licensing that was happening in there, and some of the monopolies that were in traditional IT. So they adopted a number of technologies, including things like hyper-converged, OpenStack in terms of open source, and looked at things like software-defined data center, and it's kind of got a little bit ridiculous with things like software-defined infrastructure, and then you had software-defined everything, and on and on and on. But I kind of really think that transitional IT is kind of really exactly what it says. It's transitional. You're kind of a step, in the other direction, again, going into the cloud. And really, in cloud is where really sort of obviously everything is happening at the moment. So we have obviously private clouds, hybrid clouds, etc. And kind of the first foray into that was maybe kind of, moving some non-production workloads and putting those into instances in things like AWS. So that was kind of the first sort of phase of moving into the cloud. And that's where things like shadow IT started happening, and CFOs started panicking about bills and monthly bills and things like that. So in there you saw again, for private clouds, you saw things like hyper-converged, OpenStack, and so on all happening. And then the likes of sort of containers and orchestration really sort of came in as a sort of a second phase. So while people were kind of figuring out, how to get sort of applications migrated, you had sort of containers and orchestration sort of crash the party. And again, in that area, obviously things like Docker and Kubernetes were really sort of the leaders in that space. The specific workloads, I think, have continued to really be quite a pain in terms of both how you actually migrate those, as well as in terms of the licensing. How do you actually deal with the licensing for those? So things like SAP and Oracle workloads continue to remain really in the data center, or maybe they kind of go off premises into an MSP environment. And then as we were sort of getting used to containers and orchestration, you had to kind of also contend with, reclassifying or rewriting your applications in a more agile way. So things like DevOps happened, and microservices started really coming in. And along that, technologies like obviously making your applications more modular, looking at the whole sort of, and categorizing the software development lifecycle, using CI/CD pipelines to push out your code, using Agile for actually developing your code, and automating that sort of process. And as we were doing that, and we thought, okay, yes, we're great, we've got it all nice and automated, it's all working fine, we're a DevOps shop, fantastic. And then somebody said, what about security? And I went, oh, right, yes, forgot about that. So we need to actually inject some security in there. So things like DevSecOps is now, you've noticed, you've probably kind of seen quite a lot of focus on that recently. So DevSecOps is kind of really coming in to have security baked into the CI/CD pipeline. That's, again, quite important because that needs to really comply with the rest of the organization's security policy. And obviously, the nirvana is really kind of to try and really get to serverless and infrastructure as code. That's where you sort of take advantage of things like spot instances, where you automate the whole process, and obviously, still have things like DevSecOps in there. Now, I call platforms that actually generate the environment for you as kind of world engines. I took that out of Man of Steel, I think. If anybody's seen Superman, or is a Superman fan. So basically you have, you describe the world that you want, and an engine generates the world for you. So things like AWS Lambda, etc. That's really the idea with those. And that's really what's obviously driving a lot of this sort of workloads that organizations really are trying to strive for, trying to go towards at the moment. And that's really kind of the customer journey. So the idea with this is really that you kind of show what customers is happening. You give them an opportunity to be able to actually talk about it, maybe kind of point to where they might be along that journey and what's to come, what else they can actually do as well. So it's a good way to actually have a conversation or start a conversation with customers. Okay, so on to migration strategies. So if anybody says that actually migrating to the cloud is because we can save some money, they can forget that. That's really not the idea of why you'd want to go to the cloud or why you'd want to put some workloads into the cloud. The idea is really to actually achieve sort of some of those top ones up there, things like flexibility, agility. I'm quite surprised actually that they don't have independence in this list, because one of the things that you ought to be striving for when you're actually doing it in the cloud is independence from any underlying platforms. Anyway, so yeah, that's kind of really the idea of that. So the more that you kind of aim your strategy towards those sort of higher points up there, the better that you are in terms of actually achieving your goals and taking full advantage of your cloud workloads or cloud deployments. Okay, so how can you migrate? Well, there's a number of ways that you can do it. I'm sure every consultancy out there will give you their sort of version of it. But the industry's kind of boiled down to this sort of standard of the 6 R's, the way of actually migrating applications or looking at how you can, migrate applications into the cloud. So that goes everything from keeping it on-prem, so that's actually an option, to things like retiring the application, so it's just too old, have an old CRM system, not really worth moving it into the cloud, let's just go to Salesforce. We have an HR system, again, not worth migrating to the cloud, let's just go to Workday. So that's kind of SaaS, essentially, kind of that sort of option is available. And then all the other ones, things like rehosting the application, so that's what other people call kind of lift and shift, to re-platforming, so actually just putting it on a different platform, to actually looking at getting a different solution altogether, and then down to actually rewriting or refactoring the code itself so it can be kind of more cloud native. So these are just some of the ways. I won't go through sort of all the details of that, but these are kind of some of the ways that organizations actually look at how they can migrate applications or look at actually assessing how they can migrate applications into the cloud. Okay, so one of the other areas, of course, is data. So as your application moves to the cloud, it's probably a good idea that the data goes along with it as well. So if you've got a dependency on former application looking at a database or using a database, probably useful to actually get the database or the data into the cloud as well. And there's a number of those, so I won't go through all of those there, but suffice to say it goes everything from sort of taking the data out of that database and putting it into maybe a more cost-effective database in the cloud, and all the way to moving the data across with the application, to taking advantage of new technologies that are actually in the cloud, things like analytics and AI that you can actually apply to some data that you probably had for years and years in the data center, in your own data center, and you weren't doing anything with, to actually looking at how you can apply things like backup recovery and replication services as well. So there's loads of those available, of course, as SaaS solutions. You can actually look at that as a potential solution for the data that you're handling and managing as well. Okay, so cloud native architecture. I sincerely hope that's not how you do your cloud native architecture. So what's happening here? Well, the idea really is that when you're designing a cloud-native architecture, to actually look at everything. So I just came out of a customer cloud workshop today, an all-day workshop, and we were talking exactly about this today. So not just really looking at migrating the applications, but also looking at how the overall sort of digital strategy, how you modularize your infrastructure, so whether that survives the move or is part of the move or is not part of the move, as well as actually looking at designing the multi-cloud architecture as well, all underpinned by that cloud-native design. Okay, that's really important to do. And obviously security baked in, as we said, that's really, again, part of that process. So you need really to have your security teams as part of the process, involved in the design as you go through to actually understand the mechanisms required for that. Observability, if you've not heard of that term, I'm sure you have, but observability is kind of really the way to look at everything, all the metrics, all the logs, all the data that's coming out of all of these platforms, be able to collate that and make some sense of it. It's kind of an inference to the sort of the best explanation in terms of any events and alerts and failures and problems that may occur. So all again, part of this sort of strategy. So it's really important not just to look at kind of how do I migrate my low-hanging fruits of applications, put those workloads into the cloud, but actually the entire sort of process of how you do everything is affected by that. So you need to really look at all of those aspects of your IT strategy. And if you kind of want to classify it and put it in various levels, I guess you can do that as well. So this kind of shows you where various technologies sort of fit in. So sort of infrastructure level, sort of the developer and application level, and the sort of the consumption or services level at the top. I won't go through all of that, but that just kind of helps you to define where things really fit together. I guess really probably the most important slide from my presentation is this one here. So this actually shows the cloud operating model, and the bit in the sort of the dotted lines there is really probably the two most important aspects that you need to get right in terms of how you design and architect your cloud operating model. So in terms of connectivity or networking, we're sort of seeing a shift from the data center where you run things like static IP addresses and host-based systems. So every server is a host, and it might host one application or more than one application. And we see that actually going across to a dynamic IP environment in the cloud. So we're not actually looking at the server itself or necessarily the container or the instance that's actually running, but what is the service that's actually running in that unit of computing. That's really the important thing to look at when it comes to looking at connectivity or networking in the cloud. And then similar thing really for security. So you're going from a sort of a high trust castle and moat sort of environment in the data center where once you're through the firewall, pretty much everything is, trusts everything else. Give or take a couple of service accounts. So you're kind of moving away from that sort of account-based environment into a more identity-based environment where really there's either low or preferably zero trust. So two containers sitting next to each other, two pods in Kubernetes sitting next to each other should not really trust each other. And that's really how the process works in the cloud. So going from this sort of very static data center, very kind of very defined, a very rigid way of doing things to a more dynamic, multi-cloud environment, those are the two things that you really need to look at. Yes, you need to probably kind of think about how you provision things and maybe how you operate them or manage them later, but that's really not crucial, not as critical as getting your connectivity right and most importantly getting your security right in the cloud operating model. Okay, so what can we draw from this? So, as we said, in terms of journey to the cloud, it's really about having a cloud strategy. So you must have that in place. You must actually, you actually have to do some writing. You have to actually sit down and write a document. So that is really, really important. You'd be surprised how many, organizations I've worked with that they don't actually have that. So that's really, really important to have that charter in place where everybody within the IT, team actually signs up to and supports. It's useful to have, obviously, a choice. So it's always good not to kind of put all your eggs in one basket. So look at maybe doing a hybrid. That's probably most likely the solution that you'll see. With the advent of the public cloud providers all offering sort of on-premises solutions for their platforms, it kind of makes that sort of hybrid dotted line from your data center into the public cloud even more real. So look at hybrid, look at sort of, obviously public and multi as well in the future. And again, in terms of kind of the computing unit sizes, so everything kind of, we were sort of talking about physical servers, virtual machines in the past. Now we're sort of instances and containers and serverless and so on. So all of that kind of really needs to be well defined as well and understood. So not every workload necessarily needs to go in a container environment. Not every workload needs to be in a container. It can be maybe in a serverless environment as well. So again, the unit of computing is and the size of that is really important. What kind of services can you get in there? I'm not sure you can read that, but things like look at cloud readiness. So that's kind of a service that you can go out and actually get to see whether your organization is ready for the cloud. So consultancies will help you with that. And also look at, have you got all the foundations for your cloud strategy in place as well? So Cloud Foundations is another service that you can look at. When it comes to actually migrating, so as we said, whether you're actually looking to move to the cloud, so maybe you've tried it and it didn't really work out, and you kind of didn't really manage to make it work properly, or you're probably maybe already in the cloud. If you kind of one of the more modern and startup organizations, maybe you're already in the cloud. The things to actually look for there is the migration process, as we saw earlier, how to actually do that, and how to actually try and automate that process as much as possible. So especially when kind of organizations I work with, things like the banks and the financial institutes, for example, they have hundreds, if not thousands, of applications. So we can't really sit there and go through those manually and figure out which one we can migrate. Once we've assessed the applications that can go across, we need to actually really automate the process of how we do the migration for those applications. So certainly that process is important to go through. And if you're already in the cloud, as you said, maybe you can kind of do some cost optimization. So look at kind of the expenditure and how you can change the instances or the workloads that you have. Maybe kind of shut them down overnight and spin them back up again in the morning, or maybe use serverless to do that quick financial calculation and then drop out again. And that will certainly help in terms of the costs of running things in the cloud. Again, what sort of service you can get there? Well, probably application assessment. That's probably a good idea. Look at dependency mapping. So this application needs this database, so the data in the database might need to go across, or at least the data needs to go across. And obviously things like, actually figure out what is it that you do actually have by running an asset inventory. So again, you'd be surprised at the amount of companies that actually don't know what services they have, what applications they have running in their data center, and where they are, and who looks after them, and who's the stakeholders, and so on. So that, again, this is quite important. When it comes to cloud native architecture, so look at the design for the cloud operating models. Actually make sure that you have something in place. When it comes to security, don't just copy what you have in the data center and paste that into the cloud. As we saw kind of briefly with the operating model, security is slightly different when it comes to a cloud design. So again, make sure that you understand that, and also understand all the layers of security as well. Everything kind of from infrastructure to application to data to end users and so on. All of those require different tools. All of those require different ways of implementation and how they actually work in the cloud versus in the data center. And obviously, as we said, look at applications and migrating the applications, and whether those actually end up in a managed service environment. Maybe that's actually an easier way to actually do it, and to avoid some of those costly licenses of migrating into the cloud, or actually put them maybe directly into the cloud if that's kind of more efficient and cost effective. So again, services there, you can look at actually how you do things like the concepts for the actual architecture, the cloud native architecture. Look at actually getting services for designing the architecture, writing the architecture itself, development. So maybe you have some of those applications that need to be refactored. There are obviously organizations that will help you with rewriting the applications. And all the way through to things like deployment, project management, and actually doing things like monitoring and management of the applications once they move across. I won't go through all of those, but there's obviously loads of other ones to actually consider as well. But suffice to say, the idea is that you really want to look at all of these aspects in terms of how they're actually actually operating, what are the best choices for your organization. One size doesn't necessarily fit everything in every occasion, so you need to really look at the workload, assess the workload, and see how that would really live in a cloud environment. Okay, that's kind of really the main slides I had. So I didn't talk about worldwide technologies. That's the organization I work for. So just a quick shameless plug for them. Had to do it, sorry. Yeah, so we're a global solutions provider, basically. And we are essentially an independent consultancy organization. And the focus that we have is really to provide customers sort of everything from from the point of an idea to an outcome. That's kind of how Worldwide works. And obviously we have a cloud practice. So that's really the idea of turning a full cloud concept into a reality. So we've been around for some time. I was saying earlier to somebody, probably the best kept secret of the IT industry. $11 billion turnover, so not doing too badly. Privately held, which means we're not actually answerable to any shareholders. Also, it means we are quite independent when it comes to the vendors as well. Yes, we have everybody as a partner, but actually we work quite independently. So the advice that we provide is really based on our experience and what we see as the best fit for our customers. Traditionally, they've kind of been more in the data center, but also now actually working in the cloud as well, so working with lots of organizations in the cloud and helping them to actually migrate. I think probably the best kept secret actually of Worldwide itself is the ATC, or the Advanced Technology Center. So this was actually an entire sort of data center that we have over in St. Louis. And it was always there for customers to do POCs and POVs and benchmarking and things like that. And we recently actually turned it to face the outside world. So now it's available and accessible by everybody who registers on the Worldwide website. So when you go to www.tt.com, you can actually register and then be able to access the ATC and all of the benchmarks, all of the POCs that we've done, all the shootouts that we've done for customers are all now independently, rather externally available. So you can actually look at how the technology was used, how did we put it together, look at the documentation, look at some of the engineers who actually worked on it, what were the combinations of technologies that we put together for our customers. And the best thing about it is you can actually spin up all of these workloads. So you can actually play with them yourself and experiment with them. So if you don't have that ability in your own organization, you can actually go to the ATC and be able to spin up all the labs that we already have there. And we're constantly adding more and more of these as they come online. So a really good source for technology to experiment with. Okay, and then shameless plug number 2. I'm starting a quick vlog, so just kind of putting some thoughts together. It's called the Cloud Therapists, and we're just going to be really sort of talking about various different technologies, just having a sort of an unofficial discussion about various technologies. We'll hopefully have some guests on that as well. So I have managed to twist some arms in the industry, some vendor contacts, and hopefully we'll be able to progress that and get some more out there. Right, that's it. Thank you. Any questions?
All right, this microphone is also on.
First of all, thank you for a nice talk.
Pleasure.
You showed us a graph with private cloud, public cloud. What is the data source for this graph?
Sorry, which one was that?
Your graphic, where you were showing trends for going like from on-premise to the cloud, and at the very beginning.
Okay.
Huh?
Let me do it this way. This one here?
Yep.
This one I think is Gartner.
Okay, thank you.
Any other questions? Yes, no? Maybe? Oh, sorry.
Well, there.
Hi, thanks for a great talk. So just a question around multi-cloud in organizations. So a lot of organizations are trying to avoid vendor lock-in. So they're looking to put some of the application stack in AWS, maybe some in Azure, maybe some in GCP. But of course, there's positives and negatives to that. I think from a regulatory side, maybe that's a positive. But from a data egress and from a cost economic perspective, that's something that could explode. What have you seen, and what is your advice around that? Thank you.
Yes, thank you for the question. Yeah, so I think what we're seeing is certainly a move for organizations to have a multi-cloud strategy. I have to say not everybody's there yet, but they are kind of looking at that. Or perhaps they have production workloads in one and maybe dev workloads in another. I think the advice that we probably tend to normally provide is that we actually say that organizations need to really look at independent tooling when it comes to actually doing that. So if they want to move their workloads from one environment into another one, it's not necessarily straightforward and automated, but it's certainly easier to actually do that if you have third-party tooling for things like automation, provisioning, and so on. So if you're kind of going to put all your eggs in one basket and use the tools of one vendor, in terms of how you actually deploy your workloads, then you're obviously reliant on those tools, to do the deployment. So actually moving into another cloud is going to be difficult to do that. So probably actually good idea to look at third-party tools that are available and use those, because those will always remain independent regardless of what's happening in that public cloud. There's one more question there. Yeah.
Wait, let me just grab the microphone. This is for the recordings. You don't have to call me by full name. Thank you very much.
Hey. Like for me, I mean, I'm working in a startup, I'm CTO of a startup.
Yeah.
And like one of the big questions that I guess I have is like, why would you go multi-cloud in the first place?
Sorry, can you speak up? I can't hear you.
Sorry, why would you go multi-cloud in the first place? Because obviously if you go multi-cloud, you can't use any platform as a services. You can't use any platform as services. Like let's say you want to, you have a message queue, yeah, and instead of like Kafka, you use like PubSub, Google PubSub, or you use like Amazon Kinesis. Mm-hmm. Obviously you can't use this in a multi-cloud environment. On the other hand, like you have all this like operations around like maintaining Kafka and all the things. So obviously, if you go multi-cloud, you can only do this in like an, I guess, open source environment. Mm-hmm. And yeah, I guess I'm like more generally asking like what are the benefits of like going multi-cloud other than like, okay, Amazon, it has this like one day in like every 10 years where they go down.
Yes, I think if I understood your question correctly, I think that is a dilemma, to be honest. So it's kind of dependent really on a number of factors, everything from sort of costs to the experience and the resources that you have. So if you have a team that's kind of well versed in open source and they come from that background, then they should be able to really cater for that type of workload in the data center or wherever you want to put it, whether it's in a public cloud or private cloud or on top of a hypervisor or whatever you want really in your data center. So in that situation, you don't necessarily need to be in the cloud. If kind of, you've got the skills and the capability to do that, then you can really spin that up any way you like. The problem I think we find is that not everybody has that skill set, and actually one of the things that Worldwide Technology does is staff augmentation. So we actually bring in specialists into a IT department, to an IT team for an organization to actually help them do some of the designs, do some of the standing up of these workloads, do the migration, and so on. And then we kind of do skills transfer and things like that and get them to look after it. But so that I think depends on really what kind of skill sets you have. And then I guess the second thing is whether that workload does need to be touched regularly, or it's kind of something that you can just spin up and run it. It just kind of runs happily wherever it is. So it's a number of factors that will dictate that. Does that answer your question?
Not sure.
See me afterwards if I didn't get all
I've
of
got
that.
time for one more question, and then we have to carry on to the next one. Okay, I'm not sure who had their hand up.
That's the other person.
Okay. Thank you for the presentation, quite detailed. I was wondering, from your years of experience, what do you think is the biggest hurdle? Let's say, for example, if a company approaches you, okay, we're trying to do a digital transformation onto the cloud, right? Yes. So what's the biggest hurdle? Is it that the upper level, the executive level seems to don't understand it, or is it that there's a communication gap between the IT department and the cloud?
Okay, so if I understood the question right, yeah, I mean, I think there's, you know, in the sort of in the data center, it's kind of that sort of shift in terms of sort of mind and understanding of how IT ought to be utilized. So kind of in the data center, sort of in the old days, you know, you had sort of technology where, you know, the technology was designed to help the organization to use IT, to actually use technology. Whereas now, really, it ought to be an enabler for the business. So it ought to, you know, allow things like innovation, flexibility, agility, and speed. You know, those are the things that it really needs to provide for the organization. So if it's not doing that, it still kind of, it means that you're still kind of doing it in the old way. So, you know, the thing to do there is to really try and engage with the rest of the organization, with the stakeholders, and see what is their requirement prior to making a decision to, you know, going into the cloud or putting a workload in the cloud and so on. So again, as I said earlier, it's not really just for the sake of it. You know, you kind of, you know, everyone's going to the cloud. CEO says, let's go to the cloud, so we all go to the cloud and start our migration process. It's really about, you know, making sure that if you are going to undertake that, and that is a really huge, you know, process to actually start. I mean, some of the companies I'm working with, you know, doing sort of 3 to 5 year migrations, and it's not like an overnight sort of, you know, journey that you can take. So I think it's all about really IT becoming an enabler for the business rather than just offering a service to the business. Okay.
All right. Thank you, Richard.
Thank you, guys.
I would like to invite Pradeep onto the stage for the next talk. Yes. Do you have your own adapter? Yeah, I've got mine, but I'll give you back. So there is a microphone here that works, but there's no way of putting a laptop here. So you have to hold my... Does that work?
Clicker works. The clicker?
I don't know. It's not connected to my laptop. The thing is missing. Ready? Da, 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 da. All right. Ready? Yep. Cool. Well, give a big round of applause to Pradeep.
Hello everyone. Today I'm going to talk about the Terraform and the GCP, how the modules can help.
Yeah. Okay, so there is actually a mic here, but I'm not sure if...
Okay, this is working.
I mean, it is on, but...
Okay, I will use this.
Just use that until you do the demo or something.
Sure.
Technical issues.
So will you see how the Terraform modules can help us to build infrastructure quickly, and the main thing here is to how we can test the modules which builds infrastructure on the cloud. So quick about me, I'm an IT consultant with more than 8 years of experience working in different fields like big data, the cloud and DevOps. And I offer services like big data consultancy or cloud consultancies or tailored workshops, and I'm available for projects, so you can contact me. So today's agenda is we'll see about what's the Terraform, what are Terraform modules, and how we're going to test it. As per the time, I'll try to give a demo, like how to test the Terraform modules. So Terraform is an open source tool, came out from the HashiCorp. It allows us to build the infrastructure in a really easy way, and we can manage through as a code. So the language it uses is HCL. It's a HashiCorp configuration language. It's a declarative language, so you describe your infrastructure in a kind of a plain English, and it gives you the infrastructure on the cloud, whether it's GCP, AWS, Azure, or any other providers. Its life cycle is really simple. It's a 4-stage life cycle. When you have a code ready, you do a Terraform init, which initializes the Terraform repository. What it does during the initialization is like it's going to download all the dependent modules or any dependencies, plugins, etc. to your local system and make the code ready to go. Once the initialization has happened, we can just do a Terraform plan. It gives an execution plan which will tell, okay, what Terraform is going to do on GCP or AWS or an Azure cloud. And once we are happy with the plan, for example, we want to create load balancer with few VM instances, and the execution plan looks good, we can then run Terraform apply, and it is going to then interact with the cloud APIs and going to create the resources. And once we are done with our infrastructure and we no longer need it, we can just run Terraform destroy, and it is going to destroy all the resources was built by the code. So in this way, you can quickly create infrastructure and delete it. So it's a lot easy to build infrastructure on the cloud from a development perspective, and it saves the cost because you don't just keep your resources open 24 hours. You can just bring them up when you want and bring them down when you don't need. For example, if we have a simple infrastructure like this, where we have a web servers, it could be one or multiple web servers, then you have IAM permissions attached to it. Some storage layer, it could be like Cloud SQL, storage bucket, and then your users are going to connect to a web server. So there are a few components here, like a VM instance, a storage layer, IAM, then subnet, VPCs, etc., which forms your full application. If you want to deploy this manually, maybe for one instance you can deploy it quickly, but what happens if 10 developers want to deploy the same thing? It's really hard to instruct them to deploy that stuff in the same way. That's where the infrastructure as a code tool like Terraform comes into the picture, where you describe this kind of infrastructure as a code, and you can run that code multiple times and it will give the same kind of infrastructure. So the code looks like this. So you have, you create like a service account with few lines of code. You provide what permission it needs. Then some lines to create like the storage bucket, and if you want to upload any objects on them. And another snippet to, for example, create a VM instance and attach the service accounts to it. It looks simple. But the problem is, if you have that code, it will give you the infrastructure which we saw in the previous diagram. But again, as I said, if you want to have the same infrastructure, let's say in the dev, then maybe promote it to the different environment like test or prod, queue or something like that. The problem is you need to copy that code, put in a different Terraform projects and run it again. So in that way, you have a code duplication. That's one problem. And second is, when you have a code living in, let's say, a different repository, a developer or operation person can just tweak some properties and then the code could start diverging. Another scenario could be, you have one environment, but you want to give different infrastructure to different developers. So like for developer 1, you want to give him an isolated environment. For developer 2, again, you want to give isolated environment, and so on. Again, the same problem. If you have that code, you copy the code into different Terraform projects and then run it. So that's where Terraform modules can help us. So Terraform module is kind of a function where you write you abstract your logic, you write your logic, and then you call that function multiple times. So you're passing some argument to a function, and it is going to give a similar output based on the provided values. So just a collection of all the Terraform resources which we saw. We can, if you put that in a project, that can be called as Terraform module. So what it allows is, helps us to describe the infrastructure, not only the resources. You can describe the whole application infrastructure in a module, and your developers or different teams can just use that module to deploy the similar application or infrastructure multiple times in a different environment. It's reusable because you write the module once and multiple teams or multiple developers can use it. It helps to do the collaborative development because multiple people can contribute to a module. It's not only like one team or one person has to write a module. Multiple teams can work together and write a module which helps everyone. Similarly, there are modules which is available in the open source, which probably written by maybe a one person or a community, and as they are open source, anyone can just get those modules and do the stuff. For example, if I'm starting with Google and if I want to create a network, instead of figuring out how to create a network, I can just go to the Terraform registry where I can get the open source module and just pass some parameters and it can give me the Google VPC or a network. So it helps to start quickly or do POCs or something like that. And as the code is everything is written as a code, so you put in a GitHub or Bitbucket or something like that, so you can version them easily. So once we put all those snippets in our Terraform modules, this is how simple it is to call that module. We call module my app or anything as a module name, and you pass some properties. Like the one important thing is the source, where the source of the module lives. In this example, it's in my local directory. So here you define like what's the project ID, what role I want, what machine type I want, etc. So if I have that module and if I want to just distribute to different developers and they can just pass different machine types, they'll get the similar infrastructure, but maybe with someone will have like N1 standard 1, someone will have N1 standard 2, etc. Or maybe they have a different labels. So the source can be the local path or it could be a Git path. So that's allowed to keep the code in a central location and everyone can use it. Even you can provide the version number so that you can tag or you can specifically call a version of a module. And if you want a infrastructure like in a multiple times, it's just easy. You copy the same thing or call the modules in a separate block and put some different values. For example, here I put in the label I put like a dev1 for the my app 1 and the dev2 for my app 2, and it will give the same infrastructure. It's just that label is different. So the person doesn't have to write the whole code, which you saw in the previous slide, or copy the whole code. A sample directory structure looks like this is from a different module. So it's a GCS module which is available on the above link. So the main thing is like where you have a .tf file, bucket.tf, which has the code, which describes how to create a bucket, then some outputs, variables, and I prefer to put some examples so that if someone else wants to use these modules, he or she can just refer to the examples and then can quickly get started with that. And a changelog is important because that's where when you incrementally develop your module, that's where you put, okay, what the specific version is supposed to do and what are the changes coming into the new versions. So we saw some examples of the module source, but there is an extensive list which can be found on this website, Terraform website. But yeah, it supports like local path, GitHub, Bitbucket, S3 bucket, GCS bucket, etc. This is a website, Terraform registry, so you can just search like the modules or provider here. For example, you want to deploy a HashiCorp Vault. You just search Vault. There will be some modules available, maybe by HashiCorp or some community people. You can look around and use the one which fits for your need. So how the modules can help us to build the infrastructure quickly in an organization. Suppose I want to, like I'm an enterprise organization and I want to start working with a GCP. So, and in future I will have multiple teams. So I can build like the modules which creates a different resources on the GCP. For example, there is a module which creates a project, a module to create IAM roles, BigQuery datasets, data store stuff, or other stuff like bucket, network, and so on. Once I have all these kind of modules, it becomes really easy to quickly deploy different projects or create a new infrastructure. So now, once I have these modules, I go to the Google Cloud Platform, and if I want a GCP project or multiple GCP project, I just call the GCP project module, pass my parameter, for example, project ID, and it will give me the GCP project. So I can have one or multiple projects quickly once I have the project module ready. If I want network, I can again call like the network module, create multiple, similarly for BigQuery or compute. Or if I have an app, as we saw earlier, which uses multiple components or multiple resources or services from GCP, then that app can call different modules. You can call different modules in a single Terraform project, and you can build that app. So in this way, it becomes really easy or quickly to deploy your application or build infrastructure on the cloud once you have the modules ready. Now, as we are writing everything as code, so testing is important. So there are different frameworks for doing Terraform testing. Generally use the Kitchen and the Inspect for the GCP to do the GCP testing. These are the links to get all these frameworks are like open source to get started with. So this is how the test structure looks like. So we saw the module structure. Similarly, we will have like a test folder where we will define a fixture which will have a code to create some infrastructure and integration test, where in the default, like in some Ruby files, we will define like what test we want, and these tests are like inspect test. I'll quickly show on the GitHub like how these things looks like, and a kitchen.yml to define where these tests lives or where the fixtures lives, and a gem file to define the dependencies. The life cycle is similar to the Terraform. Again, it's a 4-stage. Kitchen create, it will initialize the Terraform resources for you. Then Kitchen converge, which is basically a Terraform apply. Whatever the Terraform modules you have written, it will, and based on the values you are providing, it is going to create an infrastructure. And when we run the Kitchen verify, it is going to run the inspect GCP test against that infrastructure. And based on the test, it will say, okay, this passed or failed. And then we can just do Kitchen destroy. It is going to destroy all the testing environment. So you save the cost. You don't keep the testing environment for a long time. So let's quickly see the source code. So this is a GCS module where so like all those files. So one nice thing which I try to do is to have at least some minimum information on the README, because if someone wants to use that module, maybe within the organization or if you're open sourcing outside world, he has like few information what this module is about, like what Terraform version it supports, what input variables it expects, what's its description, is there any default value or not, and how to use this. This I feel very important, because a person just has to copy this thing in their Terraform repository and can quickly start with this. So for test, we'll just see, if I go to integration, so here's the inspect YAML file, where I define, okay, I want to use the inspect GCP. These are the values I'm going to pass to my test. And in the controls, we define what the test looks like exactly. So it's a simple test. It just says the describe, like the Google Storage bucket, the bucket name I'm going to pass as a variable. The first test is it should exist, which means if the module is supposed to create a bucket, then once the module creates a bucket, the test will say, okay, does it exist on the GCP, yes or no? And the second is like versioning enabled should be false or true, depending on what your requirement is. In this example, I've said false. So if the versioning is false on the bucket, then the test will pass. And if the versioning is enabled, then the test will fail. So you will get to know that, okay, you're not supposed to enable the versioning, but somehow you have enabled it, maybe manually, or you have tweaked the code. So this is about the testing, and I'll just quickly show the bucket.tf, which creates a bucket. It's a similar snippet. So just says Google Storage bucket, then some parameters, and you want versioning yes or no, and just passing through the variables. So let me get the terminal to quickly do the demo. Hopefully it works. Just increasing the size, let me know if it's visible at the back. It's okay? Okay, good. I was waiting for someone will say, okay, it's okay. So I have all this file. Just get this. So what I'm going to do is I'm just going to do bundle exec, which is going to download the dependencies as well. Kitchen create. Should do some little bit small. So it's going to download all those providers and like basically a Terraform init for you. Might take some time depending on the internet speed. Should work.
Should we come back later?
Sorry?
Should we come back later?
No. Hopefully HashiCorp website is still live, so yeah. It's all about the demo. Things doesn't work at the speed when you're doing a demo. God. Sorry, I can't help, like, if the internet is not working well. I'm using the Sainsbury provided internet, so I'm not sure if they ran out of the plan. So I'll quickly show here. So, like, it doesn't. Let me just try one more time and. Something wrong with the internet, it's not able to pull. It doesn't take this much time. I don't know, or HashiCorp is down or the internet is slow. But yeah, meanwhile, I'll just keep it running if it works. But yeah, see. Let me quickly just check. Okay. So now, once everything. Now. So I'm going to do kitchen converge, which is going to create, basically it's going to run Terraform apply, and it has created a bucket on the GCS. And now I'm going to do verify. I've changed the value of versioning. So I created a bucket without a versioning, and in my test I've changed and saying that the versioning should be enabled, just to show that one test pass and one test fail. Just to make sure that it works. It's not like all dummy thing. Now it's contacting Google API. So if this is slow, then it's Google. Could be. We need to check, like, yeah. So it says like one test successful and one failure. So we can just quickly go. So it says that bucket is expected to exist. So which module has created. And it says that versioning enabled is expected to be true, but got false. So and at the end it says like one test successful, failure, and overall what's the report. And if I just change that test and I say like I expect it to false,
If you use should, that means that it's okay if it doesn't.
if you're trying to translate it to exact English, then yeah, it will be difficult. So it's basically it's based on R spec. Should means like equal to. It's not the Terraform thing. It's a R spec thing. So I'm going to run the test again. So both the tests should pass now because the bucket is there and the versioning is false. So now it says like one successful control because the versioning is expected to be false and it's false. So yeah, so I think it's a QA time. Let me just go back to the slides. I think it's just to make sure that I haven't left anything. Yeah, it's questions. Yeah.
Okay, round of applause. It feels like deja vu.
Indeed it is. I honestly got slightly confused in a demo, not because of the lag with the internet, but we've been deploying a bucket in GCP with a test using a module. From my perspective, it seems slightly strange that we have to amend the test, like editing the test file, to verify that our object is deployed successfully. So surely tests should pick up whatever parameters we have provided as part of the definition of the bucket and verify compliance with our inputs, not just be a static file that we will have to edit each time we deploy a different bucket.
So when the real production, yeah, these files will be, you can have like all these things continuously. You can generate these tests based on some templates. Just for the demo, I just changed the file just to demonstrate that the test fails and pass. It's not like every time it's pass or every time it fails.
Okay, makes sense.
So it's just giving you two different scenarios.
Questions?
Thanks for the cool talk. What kind of utility does being able to test
Could you please loud?
Thanks for the talk. What kind of utility does being able to test your Terraform give you? Like, what problems does it solve? Being able to validate that a bucket's there. Do you do kind of more advanced testing that actually solves problems, or?
So basically, when you work with the Terraform, there are not many frameworks which allows the testing. So this is one of the frameworks. So when you build something on infra, like on cloud or something, you need to be sure that the resources is what you are expecting. So that's the problem it solves. Otherwise, what you will do is probably you will write some shell script to run gcloud commands to check it and all those stuff. But this test like just solve those problems.
Any other questions? This side of the room. Okay, I'll come. Hold on. Interestingly enough, there's two people having the same questions. Or the same two people have questions.
Yeah, I think my question is more about the state. How are we going to, keep the state of our Terraform? So, for example, now you deploy let's say, your plan, and then after that, actually your machine will be, like the source of truth for your execution. So, what sort of like how to keep the state of Terraform?
So for the Terraform, so for the actual infrastructure, which is not for the testing, obviously you'll have like the remote state. So in Google, it will be probably on GCS, or if you're on AWS, you could put on S3, or if you're on Azure, like whatever blob storage Azure provides, you can put there. This is for testing, so it's just a short-lived infrastructure. So in reality, this will be run on, let's say, on CI/CD pipeline. So this infrastructure will quickly come. You'll run, like the pipeline will run test, generates a report, and destroy it quickly. So it could be on local, or you could put that on the like a remote storage. So, but actual infrastructure, that state will be on some remote system.
All right, last question. All right, so I think that concludes it. Give a big round of applause.
Thanks, everyone.
All right, everyone, we'll have a 15-minute break. So if everybody could be back here at 8:30, then we'll have the last talk.